to the OPS project. Today I'm going to have a look at the phase splitter. Now its full title is a unity gain phase splitter. Now this is it's basically like a Class A amplifier but taking two outputs, one from the collector, one from the emitter. I'm surprised I haven't seen this circuit before because it is really simple and quite an easy circuit to set up, or hopefully will be. Anyway, let's have a look at it on the whiteboard and then we'll have a look on the breadboard and see how it actually works. So I've got it marked up, drawn up, shall I say, on the whiteboard here. Nice simple circuit, one transistor, biasing resistors, input via capacitor, but the difference being is that we've got two outputs on the collector and on the emitter. Now the resistors that I've put in are both the same, they've got the same value on the emitter and on the collector. This is supposedly to ensure that there's a even percentage difference between VCC and ground so that we get proper unity gain. So what I'm looking for on this circuit is actually to get about 6 volts here and about 3 volts here, so we've got a good swing. Now the input is basic sine wave, and what I hope to get out is basically two outputs but out of phase by 180 degrees, but being the same amplitude, so we have a unity gain. Looks simple enough. So yeah, let's go to the breadboard and see if I can get that working. So here's my circuit on my breadboard. It's a little circuit, resistors, a few resistors, a transistor in the middle there, which is a 2N222, capacitor for the input. Got a couple of scope probes to look at what's going to be happening on there, and that's about it. Bit of filter on the voltage input, but that's about it. 9 volts on the input. So let's have a look on the scope and see what this gives us. Okay, so I've got my scope turned on. I've got channel 1 turned on at the moment because I'm just going to first of all have a look at the input of my signal generator, which I'm going to be using 1 kilohertz at 100 millivolts. So let's turn the circuit on first of all. Bit of noise in there, but never mind. The voltage is 50 millivolts per division, so with 100 millivolts input, that's my input signal. Nice sine wave there, and yeah, that's pretty much 100 millivolts. Obviously this is a bit of spaghetti junction, so there's a slight loss in there. So if I now turn on channel 1, which has actually got my output on the emitter, then what I should have is an in-phase output. Turn that on, and there we go. Pops in quite nicely, doesn't it? Sits just in there with the input. There's a slight shift in the signal, and it's a tiny bit smaller from what I can see on the scope at the moment, but then yeah, this isn't a perfect circuit, so there you go. Now if I move my probe for the channel B and put it onto the collector output, I should now have two outputs that are 180 degrees out of phase, and they're still pretty much 100 millivolts. So yeah, so I've got 100 millivolt input, single input, but I've got two outputs now, and they are 180 degrees phase shift between the two. So it's split the signal and phase shifted it. So yeah, it's a unity gain phase splitter. So that's done exactly what I want it to do, which is brilliant. Yeah, can't say better than that. So there you go, the phase splitter. Very simple circuit. Does what I expected it to. Put one signal in and get two out, 180 degrees out of phase. So it's very easy to make, very easy to set up. I didn't have any problems with it. Not quite sure what I would use it for. I'm not really sure what the purpose of its design was. What was it designed to be used with? I don't know. I'm sure I'll have a look and try and see if I can also use this in one of my own circuits and design something and put it into. So a lot more experimentation to go on there yet, and see if I can make use of the circuit. But yeah, I do like it. It's quite simple and really easy to set up. If you like this video, give me a thumbs up, subscribe, and all comments are welcome. See you next time.